Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMAD DANIAL, and I will be representing Studio 1 in order to explain the question 1, 3, and 5. So now, this is the first question, which is, it will show us how the exchange work in the assembly language. So this is the copy of the code that has been given to us. So basically, it has 5 lines that need to be run, and I also have step over here, which is we have autos, watch one, registers, and memory in order for us to detect what value we store in it. So let us run the first line, which is load var1 into register AX. Before that, I want to explain that our var1 is now equal to 1 word, and var2 is equal to 9. So basically, 1 will be stored into register AX. So if we execute the first line, as you can see, our AX now we hold the value of 1. So if we execute the second line, which is var2 will load into the value of var2 will load into the register BX. So let us look at the register BX. We execute the line. The BX value is changed. It will change into 9. So right now, we are in the third line. So in the third line, we have a special syntax called exchange. That means the value of BX and the value of AX will be changed. So the value will be X will hold 1 and value of AX will hold 9 if we execute this line. So let me execute it and see. The both of the line is already exchanged. So now we want to make the value of AX store into var1 and value of BX store into var2. So in the line 4, the value of AX will store into var1. So as you can see here at var1, the initial is 001. So when we execute this line, it changed into 0009, and then when we execute the line 5, it also changed into 0001 based on the value of BX. So this is all about question 1. Okay, now we are at question 3. As you can see, it gives us an arithmetic expression, means var1 is equal to var4 is equal to var1 times var2 in bracket plus var3, and the total of it will be decrement by 1 and stored into var4. But I noticed that there is something wrong with this code, which means that I will explain to you guys later. As you can see, it only have 4 lines, but what I've done in my code is that I add another line, which is line 5. I will explain you guys why that I add line 5 in this code. So basically, let us track the movement of the value inside those registers and the variable. So at the first line, what have I done is that I will move and load the value of var1, which is 5, into register EAX. So when we look in this EAX, when I run it, you can see that the value of var1 is already stored in register EAX. Then I will multiply by var2, which is 10. So when I multiply by var2 and store it into register EAX, so the value that I get will be 32 hexadecimal. That's it. Then move to the line 3, which is I will add the value of var3, which is 20 decimal, with the value in the register EAX. So 32 hexadecimal add with 20 decimal, we will get 46 hexadecimal in line 3. Now in line 4, we will decrement the EAX by 1, which is we will make 46 hexadecimal minus 1, and it will become 45. Let me run it. Yeah, it becomes 45. So as you guys can see, in the fourth line, the value of var4 is still 0. It still doesn't assign the value of register EAX into the var4. So what did I do is, I add another line, which is move EAX into var4. That's why when I run this line, our var4 will equal to the value of EAX, which is 45 hexadecimal. So that is all my explanation. Time to go to the next question. Okay, so let's move to the question 5. So as the question 5 said, we need to write a full program about the code snippet that it has given in the question. So this is the code snippet that it has given to us. So this is my full program. Basically, it's just a normal program. But let me explain to you guys about what each line will be function. So as you can see here, for the first line, we have moved the x 0. Means that we want to clear our dx value. So the dx will set to the 0 hexadecimal. And then in the second line, we will load 1000 hexadecimal into register AX. And the third line, we will load 25 hexadecimal into register CX. And lastly, the fourth line, we will multiply AX by CX by storing the result in the AX. So if we think it logically, 25 hexadecimal times with 1000 hexadecimal means that we will get 25,000 hexadecimal, which is we cannot store it into a register as AX. So we use a concept concatenation by using the XAX. That means that 25,000 will divide it into two parts. So dx will hold the foremost bits, which is 0002, and AX will hold 5000. So this is what the value is supposed to be when we show the general purpose register. So as you can see here, first let me compile my code, and you can see that the code is succeeded and there is no fail. Now let us debug. Start without debugging. And as you can see here, this is all of our general purpose register and the sign flag. And as you can see, our extended AX is the 4 last bit is equal to 5000, and the X is equal to 2, which is the concept is correct. So the carry flag is equal to 1, means that this code, it has a 1 carry. There is no sign flag, so that means that the code is positive. It's a 0 flag equal to 1 because all of the bits is equal to 0, and it also has an overflow occurs, and the parity flag is equal to 1 because the result of bit 1 is even. So basically this is what happened in the snippet of question 5.